Welcome to aminacademy.com. In mathematics of quantum mechanics, let us do Euler's formula and the polar form, some solving problem. Look at this. If z a complex number is a plus bi, find z dot z bar. That means product of the complex number and its conjugate. We call a plus bi, the conjugate is a minus bi, which is equal a square minus abi plus abi. Bi into bi is b square I square, which is equal plus here plus bi square minus bi square, which is equal a square, this square, I square is minus 1, therefore which is equal plus b square. A square plus b square is modulus of z square. Second one, find z plus z bar, which is equal a plus bi plus a minus bi. So this square, which is equal to a, that is sum of the complex and its conjugate is a real number, that is 2a. Third question. Now if z1 equal a plus bi, z a1 b1i, z equal to a2 b2i, like that, then find z1 plus z2 bar, which is equal a plus bi plus a1 b1i plus a2 b2i whole conjugate, which is equal, collecting the real terms a1 a2 and I into b1 b2. Yeah, this conjugate of this complex number, real part, imaginary part is separate, so which is equal a1 plus a2 minus b1 b2i, which is equal further you can write a1 minus b1i, then a2 minus b2i, which is, this is z1 bar plus z2 bar. Therefore, you proved z1 plus z2 bar is like. Similarly, you can prove Z1 into Z2 is equal Z1 bar into Z2 bar. Similarly, we can prove. Next question, by Euler's theorem I can do. Question number 4. Look at here. If Z equal e power minus I pi by 3 and W another complex number in polar form, that is e power I pi by 4, then find Z into W. So we have to find Z into W, which is equal e power I pi by 2 into e power I pi by 4. That is both product. First Z equal to e power minus I pi by 2 and W equal to e power I pi by 4. Here that will be Z equal to W equal to 4. Let's see, 4. So Z is given, W is given, so product is this. Further 4 is a common and e power minus I pi by 2 e power I pi by 4, which is equal 4 e power minus I pi by 2 plus I pi by 4, which is equal 4 e power minus I pi by 4, because minus half plus quarter is minus quarter, which is further we can write it's equal 4 times cos of minus pi by 4 plus I sin of minus pi by 4. We know that cos of minus pi by 4 is pi by 4. It is cos pi by 4. Sin of minus pi by 4 is minus sin pi by 4 here, so it becomes minus. That is I sin pi by 4. Put the values for both. We have 4 into cos pi by 4 is 1 by root 2 minus I into 1 by root 2, which is equal 4 by root 2, 1 minus I. 4 by root 2, you can write 2 root 2. 2 root 2, 1 minus I. That means 4 can be written as 2 into root 2 into root 2, 1 root 2 cut, so 2 root 2. Next one. If if z equal 2 to e power I pi by 2, find z power 4. Fourth power of z you have to find. Here z power 4 equal, the modulus is 2. Here 2 power 4 e power I pi by 4 whole power 4, which is equal 2 power 4 this, let it be this e pi power 3, not 4. Then pi by 3, 2 power 4 e power I 4 power 4 pi by 3, which is equal to 4 4 is 16. Then here cos 4 pi by 3, 4 pi by 3 plus I sin 4 pi by 3. So we are putting the values of cos and sin. Here cos 4 pi by 3 is minus half and sin 4 pi by 3 is minus root 3. Minus root 3 by 2. So to take out 16 by 2 minus also take out is 1 plus root 3. 1 plus I root 3. So far we discussed some different types of problem regarding Euler's formula and polar form in mathematics of quantum mechanics. So it's useful quantum mechanics, this problem we have done. Please subscribe our YouTube channel.